Alright, this video is going to work with percents where concentrations are concerned. There's two ways to do percents when you're talking about concentration. One is percent volume and the other is percent mass. And I crammed my formula in here, but any percent is a part over a whole. So when you talk about a solution, there's two parts to a solution. There's the solute and there's the solvent. The whole would be the solute and the solvent together. That would be the solution. The main thing in question is usually the solute. So to do percent by volume, we put the volume of the solute over the volume of the solution, and then you multiply it by 100%. To do the percent by mass, we take the mass of the solute and divide it by the mass of the whole solution and multiply by 100. So here's a couple of examples of that. I'll pull my formulas back down if we need. The first one says if 10 milliliters of propanone or acetone is diluted with water to a total volume of 200 milliliters, what is the percent by volume of propanone in the solution? Well, if they're asking me percent by volume, then that means I need to be looking at this first equation right here. I need to have the volume of the solute. Well, the volume of the solute is the propanone, and there's 10 milliliters of propanone. So it's going to be 10 milliliters of propanone. And if it's diluted to a total volume of 200 milliliters, that's going to be the volume of the solution. So I'm going to put 10 divided by 200. Now notice I did use milliliters in here, and it's perfectly acceptable to use milliliters here because they're both the same. So there's not a problem with that. That's going to end up being multiplied by 100. That's 5%. That's a 5% propanone solution. The next problem says a bottle of hydrogen peroxide, like you could buy at the grocery store or drugstore, is labeled 3.0% volume by volume is what that means, that it's a percent volume. How many milliliters of H2O2, that's hydrogen peroxide, are in a 400 milliliter bottle of the solution? Well, this one's a little backwards, but mathematically you guys should be able to do this. So this time they're giving me the percentage. Well, then that's going to be equal to the number of milliliters of X milliliters of H2O2 over 400.0 milliliters of solution. But don't forget that this is multiplied times 100. So in order to solve for my x, the first thing that I'm going to have to do is get rid of the 100 over here on the side. A lot of my students would forget about this. So the very first thing that I'm going to have to do is divide both sides by 100 in order to get rid of this one. So that's going to change my 3 to 0.03. And then I'm going to have to multiply by the 400 to get it out of the denominator. And that will give me an answer of 12 milliliters of H2O2 as my answer right there. My last one says you want to make 2,000 grams of a glucose and water solution that's 2.8% glucose mass by mass. How much glucose should you use? So, well, this time it's kind of like last time that it's a little backwards. They gave me the percentage, but this time it's the mass equation instead of the volume. Really doesn't change anything about how I'm going to work it. So I have 2.8% is going to be equal to some number of grams of glucose, C6H12O6, over a total of 2,000 grams of solution. I can use grams here. I could use kilograms. As long as the top and the bottom are the same, honestly, it wouldn't matter. And then again, don't forget that I had to multiply this number by 100 in order to get 2.8%. So that means I'm going to have 0.028 times 2,000. So that gets me an answer of 56 grams of glucose in order to make that kind of a solution.